Okay, we are going to take a topic, memory management. Memory management, if you remember, is a function of an operating system. So we are going to look at it as a topic. Memory management refers to the process of managing the computer's memory by ensuring that they are used efficiently and effectively. It involves allocation, tracking, and free memory for processes to run. Also, running on a computer system. The main goal of memory management are to efficient use of memory, that is ensuring that allocated memory and allocation is needed. Also, we have isolation, virtualization, protection, and swapping. Memory management involves techniques such as paging, segmentation, and the user swapping technique also to ensure all active processes have enough memory to operate efficiently. Let's look at virtual memory memory paging as a concept of memory management. Virtual memory is a memory management technique that creates an illustration of large and continuous memory space for processor. Even if the physical memory that is around is limited or is low, it allows the system to compensate for physical memory by temporarily transferring data from RAM to storage, that is the hard disk. This process is transparent for the user and it helps to improve system performance by allowing the system to handle more processes than it expected or than the possible physical memory alone. The key benefit of virtual memory is process isolation, larger address space, and efficiency. Let's look at paging. Paging is also a memory management technique which is used in virtual memory system to divide the virtual memory and physical memory into fixed block or size called pages. The operating system maintains a page and a table maps virtual address for physical pages in the RAM. When a process accesses the data, the operating system checks the page table to determine if the data in the RAM or if the data is not in the RAM for swapping. We have key common paging. We have the page table, page frame, and we also have the page fold. So if you look at it, paging helps in utilizing physical memory more efficiently and allow process to work with a larger data set by swapping page in and out of the memory when needed. Now we look at the swapping. Swapping is a memory management technique also used by the operating system to handle situation where there is insufficient physical memory, which is the RAM, available to run all processes. When the system runs out of RAM, it moves active or less critical processes to the reserve area in the secondary storage, which is the hard disk, known as swapping space, to free up the memory active processes. This process of moving data between RAM and disk, which is known as the hard disk, is called swapping or paging. Alright, let's look at the processes of swapping. When the operating system detects the physical memory is down, it may perform the following steps. The first thing it will do, it will identify inactive process. The system check all the processes and find out the one that is not actively using the memory. So therefore, it will now swap process to disk. That is, it will swap that exact process that is inactive or not using the memory to the hard disk. Then it will now free, after it takes to the hard disk, then it will now free the memory space. Then it will swap in the needed process that want to access the RAM. So that is what happened in the swapping process. The first thing it does, it identify which memory is which process is inactive. Then when it identifies the inactive, it will now swap it from the memory into the disk. Then it will now bring the new process that want to access the memory. It will now bring it to the free space. That is what happened in the process of swapping. Alright, now we are going to look at the needs for swapping. Number one, we have memory overcommitment. Sometimes the system needs to allocate more memory than the available physical memory, which is the RAM. So swapping allows the system to use the disk space as additional memory. Also, we have multitasking, a situation whereby one single process or multiple processes are executing simultaneously. So swapping helps in managing multiple processes even when they execute the available random access memory. Then we also have handling large data sets as another also need for swapping. Alright, so we are going to look at the differences between swapping and paging. Swapping and paging are both memory management techniques which are used to move data between RAM and secondary memory, but there are key differences. Swapping typically involves moving an entire process between RAM and disks. When a process is swapped out, it moves entirely from the memory to the disks. While paging, on the other hand, divide the process into smaller fixed blocks and moves the pages out of the memory as needed. Paging is more granular and can also swap out only specific pages, while swapping move the entire process. So this marked the end of our today's class. So in summary, we have looked at swapping. We can say swapping is a fundamental technique of modern operating system that allows the system to efficiently manage memory resources. While it prevents memory storage shortage from causing crashes, it can also introduce performance overhead. The key to effective swapping is balancing between physical memory and swap also spaces.